Welcome to Brain Vision.
We need to find the forces exerted at the point E and the point F whenever this log of 800 pounds is lifted up using the tongs. So I've drew out this free body diagram, and the first thing we're going to do is find the angle theta in the free body diagram. And when solving this problem, we're going to assume that AC, the lengths from AC and lengths from BD are on their own axis. So to find angle theta, we can write that as tangent inverse of 2.5 divided by 3. And this will give us an angle of 39.805 degrees. And now we're going to say that the sum of forces about the y direction is equal to 0. And we're going to solve for the forces at point A and point B. So we can write that as 800 minus A of y minus A of B, A of x, sorry. So 800 minus A of y minus B of y is equal to 0, which we can also write as A of y plus B of y is equal to 800. So now we're going to take the moments about the point B. So the sum of moments about point B is equal to 0. And we can write that as A of y times 3 minus 800 times 1.5 is equal to 0. And solving this expression for A of y, we'll get a force value of 400 pounds. And we can now solve for the magnitude of the force at A by saying that the magnitude of force A is equal to, so we write that A of y is equal to the magnitude of the force A times the sine of theta. So we take this equation, solve for A, and plug in the known values. So we're going to have that A is equal to A of y, so A of y divided by the sine of 39.805, and this will give us a force of 624.819 pounds. We can now solve for the x component of the force by saying that A of x is equal to the magnitude of A times the cosine of theta. So we plug in A and we plug in cosine of theta. So plug in A and then times the cosine of 39.805 degrees. And this will give us a force of 480 pounds. So we go back to this equation. So we can use this equation now and solve for the y component of the force at point B. So we're going to have 400 plus B of y is equal to 800. And solving this for B of y, we'll get a force that is equal to 400 pounds. And we can say that since the system is Since this system is symmetrical, we can say that A of x is equal to B of x. So that means that the force B of x is going to be equal to 480 pounds. Okay, next we're going to start solving for the forces at points D and point E. So to start with, we can say that d of x, the x component at point D of the force, is equal to the b component, the x component of the force at point D. So we know that d of x is going to be equal to 480 pounds. And we can do the same thing for the y component. So d of y is equal to b of y, which will give us a y component at the point D of 400 pounds. So we're now going to solve for the force at point E. So we can write that the sum of moments about the point F is equal to 0. And we can write this as d of y times 10.5 plus d of x times 15.5 minus e of x times 12 is equal to 0. And plugging in and solving for e of x, we'll get a value of 400 times 10.5 plus 480 times 15.5 minus e of x times 12 is equal to 0. So we solve this for e of x. Let's give us a force of 970 pounds. And there's no y component at the point E of the force. So we can say that this is also equal to the force at the point E. So now we're going to solve for the force at point F. So to start, going back to our free body diagram, we're going to be concentrating on points D, so point D and point F, and also point E. So we're going to be focusing on that tong component. So we can say that the sum of forces about the x direction is equal to 0. And we can write that as negative d of x plus e of x minus f of x is equal to 0. And we can plug in and solve for the f of x component. So we'll get negative 480 plus 970 minus f of x is equal to 0. And solving for f of x, we'll get a force that is equal to 490 pounds. So we're now going to take the sum of forces in the y direction, set it equal to 0. And we can write that as d of y minus f of y is equal to 0. Now we plug in and solve for f of y. So v of y minus f of y is equal to 0. And solving for f of y, we'll get a value of 400 pounds. So we know the x component and the y component of the force. So we can now find the magnitude of the force. So the magnitude of the force at the point F is going to be equal to the square root of the y component squared plus the x component squared. And this will give us a force of 633 pounds. And to find the direction of this force, so the direction of this force is going to be equal to the tangent inverse of the y component over the x component. And this will give us an angle 39.2 degrees. So we can say that force at the point F is equal to 633 pounds, which is pointing in the downwards direction at an angle of 39.2 degrees. And one more thing. So this force at the point F of V, this force was acting in the right direction. So to clarify here, this force is going to be acting in the right direction. So this is going to be in the right direction. I'll write that down at the very bottom. So F of V is equal to 970 pounds in the right direction. And these are our final answers.